All right, in this section, we're going to add and subtract algebraic fractions. And just like with numerical fractions, we have to make sure we have a common denominator before we can add them together. So when we begin that process, we always start by just factoring the denominators. It doesn't matter if we factor numerators. In fact, leave the numerators unfactored, even if they would factor. So you factor the denominators. So we're just starting out with this numerical example. 6 is 2 times 3. 7 is 3 times 5. And then what you do is you ask yourself the following questions. You say, okay, what factors are present in the second denominator here that are not present over here? We can see that it's missing a factor of 5. So we want that first fraction to have a 5. We're just going to go ahead and add a factor of 5. And we're allowed to do that as long as we also add a factor of 5 in the numerator. Then we turn around and ask the same question for this other fraction. The second fraction is missing a factor of 2, so we're going to give it a factor of 2, which we can do as long as we multiply by 2 on the top as well. So 2 times 3 times 5, that's 30. So 25 over 30 plus 14 over 30. Now we have a common denominator. So if we have a common denominator, we just bring that denominator over. Then we do this operation up top. So that's 39 over 30. And then finally, anytime you're giving an answer that is a fraction, we should check to see that it's reduced. So in this case, we could factor both 39 and 30. 39 is 3 times 13. And 30 is 3 times 10. So those 3's cancel, and we get 13 out of 10. 13 tenths. All right, so now we're going to do some examples with algebraic fractions. We're going to start with 620. You'll note that already we're starting off with the same denominator here, which means that we're pretty much ready to add or subtract as indicated here. So I'm just bringing over that denominator, that common denominator, and then I'm just doing these operations, the addition, subtraction, on the numerator. So we have b plus 1 minus. Now, this is really important. I'm subtracting the whole numerator, so I need parentheses. And then we're going to just simplify what we have going on up top. So we have b plus 1. I'm going to distribute that negative. Minus 2b plus 1. And that gives us minus b plus 2 all over ax. And whoops, forgot my denominator up here. So there is our result there. In example 621, you'll note that we don't start out with a common denominator. We have to get that denominator. However, there's no factoring to do. All of these denominators are already in a factored form, so we're kind of ready to just add in any factors that we might need. I'm going to start just by rewriting it so I have kind of space to write out any needed factors. So we have 2 over 3r squared plus 4 over rs cubed minus 5 over 3s. So we have 3 fractions here. I'm going to look at this first one and just say, okay, what factors are present in any of the other 2 denominators that are not here? And we need to pick up an s cubed. And then it, I think, has all the factors that are present in the other 2. In the middle, this has to pick up a factor of 3. But it also needs to pick up a factor of r to bring us to the r squared that we have in the first denominator. And in the last fraction, we have to pick up the r squared. And we need to pick up an s squared to bring us up to the s cubed. So now our common denominator is 3r squared s cubed. Up top, I'm just going to perform these, the addition subtraction on the numerator. So we have a 2s cubed plus 12r minus 5r squared s squared. And there's our result. All right, let's try another one. In example 622, now this is the first time we're seeing fractions where we have some addition or subtraction happening in the denominator. We want to always, when you're adding and subtracting, the first thing you need to check is, can you factor the denominators? Now, there is no factoring to do. X plus 1 doesn't factor. X minus 1 doesn't factor. But what we also need to understand is that x plus 1 and x minus 1, those are distinct factors. They have no factors in common. So if we want to add these together, in order to get a common denominator, then this first fraction, right? If I say, what factors does the x minus 1 denominator, what factors does that need to pick up? It actually has to pick up the x plus 1. Those are completely different factors. They have no factors in common. So we're going to multiply the top and the bottom by x plus 1 for this first fraction. And likewise, in this second fraction, that denominator has to pick up the factor of x minus 1. Now the common denominator is the product x plus 1, x minus 1. And up top, I'm going to just perform the addition on these numerators. So I've got a times x plus 1 plus a times x minus 1. And there's a couple different ways we could approach simplifying. One pretty straightforward way is just to do all of the distributing and combine like terms. And if we do that, we get ax plus a plus ax minus a all over x plus 1, x minus 1. And then we can combine like terms, right? So the plus a, the minus a cancel. So we have 2ax over x plus 1, x minus 1. In this case, we actually had another option for simplifying the top. Just going to take a couple minutes to look at that. And it's because there is a common factor up top, right? There's a common factor of a. So you could choose, instead of distributing everything, to factor out the a, and then we have x plus 1 plus x minus 1. And then the plus 1 minus 1's cancel. And this is 2x times a, so that still gives us the 2ax. Let's do another one. So here we're going to add these three fractions. This time I think we do have a little bit of factoring to do in the bottom. So I'm going to start by rewriting. I always want to rewrite to give myself plenty of space, because I want to be able to write in and added factors that I need in the top and the bottom. And it's helpful for me if I have enough room to write that in without having to kind of squeeze it all together. Now the 2x and the x plus 1, there's no factoring to do there. But this last denominator, we could take out an x, so that's x times x plus 1. So now, if I'm working with this, the least common denominator, right, what I'm going to build up to is just making sure I have all the factors that are present without grabbing anything extra. So the LCD here means I got to grab the factor of 2, and I need to grab the factor of x. I need to grab this factor of x plus 1, because that's not already represented in 2x. But then when I go to the third denominator and make sure, see if I need to add anything, the x and the x plus 1, those are already represented here. So I know what my LCD should end up being. So if we go through and add the factors that are needed, the first fraction, that needs to pick up a factor of x plus 1. The second denominator needs to pick up a factor of 2 and a factor of x. The third denominator needs to pick up a factor of 2. So my common denominator is 2x times x plus 1. And so up top now what I have, I'm just going to kind of bring these products straight down. I've got x minus 4 times x plus 1 plus, and then I've got 2x times x plus 2 in the middle. And then I'm subtracting 2 times 3x plus 2. And so I'm just bringing those products straight down, those numerators down, and now we need to do some multiplying and simplifying. Now note that in all of these problems, right, the denominator stays factored. Leave this factored. It's not that you're not allowed to multiply it out, but it gets us nothing. It does not give us any advantage, and it is almost just extra work with no benefit. Now, what we have to do is simplify the numerator, which means we do have to multiply out the individual products. We like seeing things in factored form. The bottom's in factored form. The top is not in factored form, and I can tell that it's not in factored form because of this addition and subtraction that we have going on in between the products. So what we're going to do is multiply these out. So let's start with that product there. If we FOIL that out, we get x squared. Let's see, minus 4x plus x is minus 3x, and then minus 4. Now we'll move on to the middle product. So that's going to distribute the 2x, so we get plus 2x squared plus 4x. And then the last product here, I'm going to distribute the 2, and I'm actually going to go ahead and distribute that negative at the same time, so I'll do the multiplication and the subtraction all at once. So we have a minus 6x minus 4. This is all over our common denominator of 2x times x plus 1. Now that we've multiplied everything out up top, we can combine some like terms. So I think I'm going to bring this down here. So 2x squared, x squared, that's a 3x squared. Minus 3x plus x is a, minus 3x plus 4x is a plus x. Minus 6x is a minus 5x. And then last, minus 4 is minus 8. All right, so we have, we've ended up with this single fraction. Anytime you're giving an answer, you're finding a result that is a fraction, you want to make sure that it's reduced. So the last step is just to see if the numerator factors, and if it does, if you end up with common factors. A lot of the time that doesn't happen, but you still want to just check. So let's see, 3x squared minus 5x minus 8, if it factors, we'll need a 3x and an x. And we need two numbers that multiply out to -8 and then give us the outside-inside terms combined to give us a negative 5x. Which I think actually we can factor. I think a 3x minus 8 and an x plus 1 will work, because this is minus 8x plus 3x, which gives us the minus 5x. So this is all over 2x times x plus 1. And last we see that in fact we do have a common factor, so let's cancel those x plus 1's. And our final simplified result is 3x minus 8 over 2x. Okay, so we're going to finish this section talking about complex fractions. Complex fractions are just fractions within fractions. Fractions within fractions are never simplified, right? Like if we want to write something as a fraction, we want the numerator and denominator of a fraction, but each of those things like doesn't have fractions that live inside it. So there's actually two approaches, okay? So I'll call this, you know, when I kind of describe our approach here, I will call this method 1. And method 1 is pretty simple as a concept. It's just simplify the numerator and denominator by themselves, kind of treat them as their own little addition subtraction problems, and then do the division on those fractions. So in this, we'll see this play out in this example. 1 minus 1 over x minus 1 over x squared. So I'm just going to tackle the top and the bottom by themselves. The top is 1 minus 1 over x. Now I want a common denominator. This 1 is, of course, 1 over 1. You can get a common denominator just by multiplying by x. And so we have x minus 1 over x. In the bottom, we're working with x minus 1 over x squared. X is, of course, the same as x over 1. So we're going to get a common denominator of x squared. So that first fraction needs to pick up an x squared, and this gives us x cubed minus 1 over x squared. So here's a little side work, and which I'm going to use these results up here to rewrite this. So up top, I've got the fraction x minus 1 over x, and I'm dividing that by the fraction x cubed minus 1 over x squared. We know how to divide fractions. We're going to multiply by the reciprocal, right? You divide by a fraction by multiplying by the reciprocal, so I'm going to rewrite this as x minus 1 over x times x squared over x cubed minus 1. Now we've turned it into a multiplication problem. We know how to approach these. We're going to factor and see what cancels. So x minus 1 over x times x squared. There's only one thing here to factor, and that is the difference of cubes here, x cubed minus 1. So this is x minus 1 times x squared plus x plus 1. Now we cancel whatever we'll cancel, the x minus 1 with x minus 1. Here's a factor of x with one of these factors of x that we have there. And what we're left with is x over x squared plus x plus 1. So there's one way to approach these complex fractions. There's another method that I'm going to describe on the next page, and we'll see it play out. I want to just emphasize that either of these two methods, either of them will always work. It's really just a matter of preference and what approach you like to use. So method 2, which isn't typed up, but I'm going to write it out here. The other option we have is just to multiply the top and bottom of the, what I would call the big fraction, right? The overall fraction that we're working with, by the least common denominator, so by the LCD of all the little fractions inside. So in example 625, we can try this out. The first thing I want to point out about 625, this example, this fraction here, is that it might not at first look like a complex fraction. However, we know what negative exponents mean. We know that negative exponents means that something's in the denominator. Now, what's really important here is that when we see these negative exponents, like this x to the negative 1, that doesn't mean we throw this down here and write it as x to the first, because that's not a factor of x to the negative. If it were x to the minus 1 times a bunch of stuff up top, then I could do that. But we're adding, right? So that x to the minus 1 is not a factor. I can't throw it in the bottom of the big fraction. What I know is that x to the minus 1 is its own fraction. It's 1 over x. And then 2y to the negative 2. Note that the negative 2 exponent is only on the y. It's not on the coefficient of 2. So that is the fraction 2 over y squared. And the bottom, we've got the same fractions here, but we're just subtracting instead of adding. So we've got 1 over x minus 2 over y squared. So look, if you have negative exponents in a fraction, that means you have fractions within fractions. It is not simplified, and we want to make sure that we go through the process to simplify it. So this method here says we're going to multiply the top and the bottom of the big fraction by the LCD of all the little fractions. So if I look at all the little fractions, which is just 1 over x and 2 over y squared, the LCD here is xy squared. So what we're going to do is multiply the top and the bottom by xy squared, like so. And then we're going to distribute. So that's what it looks like in the top, and then in the bottom we distribute. And I'm writing these factors of xy squared as xy squared over 1, just to make the multiplication kind of be more conducive to the multiplication, seeing it as a factor on top, and then observing what I can cancel. So here, if I start up top in this first term, that x will cancel with that factor of x. In the second fraction up top, this y squared cancels with that factor of y squared. So that means that in the numerator, what we have is y squared plus 2x. In the bottom, we get the same canceling to happen, right? That x cancels with that x, leaving us with just the y squared. In the second term, that y squared cancels with that y squared, and that leaves us with 2x. So in the bottom of this big fraction, we have y squared minus 2x. And this is the simplified fraction. That's as far as we can go. We can't cancel over addition, so we know that we cannot cancel the y squareds. We know we cannot cancel the 2x's. These are both factored. There's no factoring to do, so there's no more canceling.